Question number 5. The customer flow at a grocery store can be viewed as a Poisson process. And we're given the probability, the number of customers arrivals in the first t timestamps equals k. And here's the formula to calculate that probability. And now we know the probability that in 2 minutes at least one customer arrives equals 0.3. And here we can immediately know that the complementary part of this would be in 2 minutes no customer arrives. Right, and that probability equals 1 minus 0.3, which gives us 0.7. And here we can just so t would equal t would equal 2 and k would equal 0 here. And then we basically have e to the power of minus 2 lambda is 0.7. And we can get the result of lambda being minus ln natural log 0.7 divided by 2, which roughly gives us 0.1783. All right, and the next little question, find the probability that in 3 minutes no customer comes. And this is pretty easy. This is basically asking us to use the formula after we found out about lambda. And 3 minutes, so t equals 3, and no customer, k equals 0. And pretty much we get e to the power of minus 3 lambda. And 3 lambda to the power of 0 is 1, and the denominator is also 1. So we have eventually 0.5857. Okay, so next question. Find the probability that in 10 minutes at least 2 customers will arrive. So at least 2 customers, that means it can be 5, it can be 100, it can be 1,000. But it is much easier to calculate the complementary part of this because we're talking about a discrete scenario. Customers can only come in integer numbers. So it's much easier for us to calculate the possibility when there's 0 customer and there's 1 customer, and the rest would be at least 2 customer. And here we can, so within 10 minutes, if there's no customer at all, then k would equal 0. If there's 1 customer, k would equal 1. And then we can do our little math here. And eventually we can have this result of 0.5321. And the last question is for us to find the probability that in 1 minute exactly 1 customer will arrive. This is also pretty easy. Pretty much we're saying that t equals 1, 1 minute, and then k equals 1. Right. So eventually we'll have this e to the power of minus lambda times lambda, and eventually we'll have a 0.1492 probability that 1 customer will come in 1 minute.